Good afternoon. Today we're going to show features that we've added in version 1.07 of the Inkjet Recipe Creation Software. We're going to use this CAD1 rectangle drawing as our example because it has two separate master cells. We'll be able to show how you handle that. We start with explode nested blocks because these blocks are heavily nested and have to be exploded. Say yes. And it has multiple levels of nesting, so we have to explode it one level at a time. And now on depth level 3, you see there's over 10,000 blocks that need to be exploded. So this may take a while. All of our blocks are exploded, and I'd like to turn off the layers I don't care about. So I'll go to the Layer Manager, and we'll turn everything off except for, say, layer 10. We'll make layer 10 the current layer, and this is what we see now. The first thing that we notice if we zoom in very tight is that this cell is made up of a number of closed polylines, but that they're not a single closed polyline. There's many of them and they overlap. In order to get the proper contour, we're going to have to use the union function. We'll go to Inkjet Recipe and we'll select Poly Union, and that'll unionize any overlapping polygon. And now I'm going to select Window from here to here. It's going to create them on ACS Poly Union. It's done. We see now there's a new layer called ACS Poly Union, which contains our unionized polygons. So we'll turn off L10. And now if we zoom in here, we'll see that we have an outer boundary and then we have a number of inner boundaries. The outer boundary is the one we're going to use to define our cell. There's no more overlap where there was before. The next step is to define glass parameters. We have to enter the units. This particular drawing is in microns, and we enter the size of the glass. I'm going to put in a number like 750,000 by 375. We also can control the bitmap of the cell. We're asking for 3000 dpi. And we can use arcsag or arc resolution to define how smooth any curves will be. Now this is new in 107, cell ordering. And you can see that there's two parameters. One of them says, do we start horizontally or vertically? The cell nearest the alignment mark will be the first cell. If you pick horizontal, it'll go horizontal first. If you pick vertical, it'll go vertical first. The pattern is either zigzag, in which case it starts here and then zigs back to here and goes again and goes again, or it's serpentine, where it runs this way, then down, then over, then down, then over. So I'll just leave these two as the default and I'll click OK. Now we have to define an alignment mark. There are no alignment marks on this layer, so I'm going to turn on layer 4. We can zoom in here, and let's say that this is the alignment mark we want to use. We want to use that corner. Define alignment mark. I'm going to snap to the intersection of these two lines. And so that's my point. That's in the upper left. Once we've done that, we can go to select the master cell. I will select this guy as the master cell. Let me zoom in to make sure I pick the outer boundary. There we go. Now that we have a master cell, we can pick the cells that match it. Find the matching cells. Just use a window. Click there, hit enter, and you see that it found some matching cells and it's also numbered them. Notice that they're all start with 1, which means this will be the type 1 cell, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and because we selected zigzag, we come back to the beginning and go 10, 11, 12, 13, 14, 15, 16, 17, 18. Notice that these were not marked, so they actually don't match the first one. So we'll repeat that process. Select master cell, and this time we'll come in here and select the outer. And now we'll say find matching cells. And it doesn't matter if I select these again or not because they don't match. And hit enter. You can see it found the balance of the cells. Notice that 17, 18, now we come back here, 19, 20, 21, 22, 23, 24, 25, 26, 27. So we continue the same pattern and we pick up numbering where we left off with the previous cell. All right, now that we've defined all of our cells, we get to the point where we export the bitmap. We can pick a bitmap name. It actually produces two bitmaps since there's two masters, and they'll be labeled with the name of the master. So type 1 was our first one, and type 2 is our second. I'm going to go straight to the recipe file. We pick our recipe file, and of course there's only one recipe file. And now let's view it. Let's go over the sections. Start with the glass section. It gives us the units, the location of the reference, the width and the height. Then these are halftone parameters. Here's a summary. It tells you how many master cells, the row and column count, how many of each type. Now we define the first master cell. We have computed its width and height of the bounding box. We provide the path to its bitmap and how many points are in the boundary. And then we give the XY coordinates. Now we repeat for the type 2, again the width and the height, the location of the bitmap, and then the coordinate points. Once we've done that, we can place all of these cells. You see that this is type 1 cell 1, type 1 cell 2, type 1 cell 3. And when we've exhausted all of those, we continue on. Type 2 cell 19, 20, 21, 22, until we get to the end. The new features are the ability to support multiple master cells, and the ability to control the ArcSag and ArcRes, and the ability to control the order of the output pattern. Thank you.